Hey guys, welcome back. In this module, we are going to discuss about how we can wire the transistor based output, which is a sourcing type. So sourcing output is what we call that. How to do the wiring of that? Let's learn. So first of all, this is a PLC. Now we'll be handling Omron, Sysmax CP1L, as you can see here. And this is very common on the ships.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, और अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mother.
Now, on the top, you will see inputs, and at the bottom, you will see outputs. Here, there is a battery chamber, some peripherals, some LEDs here, power LEDs, run LED, alarm, all those things. Then these are covers. Maybe you can connect some communication module over here. Anyway, the bottoms are the output. This is what we are mainly concerned about. By the way, is it a relay based output or a transistor based output? Well, right now I have to find the label, the full label. This is the series here. Just by looking at it, I will not come to know. But the full label or the manual will tell me whether these terminals are relay based or transistor based. If they are relay based, then I don't need to even focus about the polarity, because relay, the potential free, and also there is no concept of polarity. You can connect positive, negative, any side. That doesn't matter. You can connect AC or DC. It doesn't matter. But if it is a transistor based output, first of all, you have to use DC in the outputs. And even with DC, you have to be mindful of the polarity. So when we say the output is sourcing type, what does it mean? That means the output will become the source. Right? Current will come out of the output. So, but then it is confusing how to read this. Well, there is an easy method to read this. You will find something like this in the manual also, but I will help you find out what is this, how to interpret this one, by the way. Let's do that. So this box, as you see, and this box, they have a common boundary, as you can see. They have a common boundary. Similarly, as you can make out, this one and this one is having common boundary, a thick line here. That means they are basically one system. This terminal has its common here. This terminal and this terminal has a common here. So this common is belonging to two outputs. This common is also belonging to two outputs. However, this common belongs to only one output, like this. Similarly, this common belongs to only one output. And internally, they all are separate. That means this red one will be, I'll show you. This red one and let's say this green one are totally different. Internally, they are not connected. Meaning, red common is giving output to 0, red 0. Green common is giving output to the 1, green 1, right? And there will be internally, there will be switch between the two. So between these two, there is a switch. Between these two, there is a switch. That switch is operated by the PLC. So whatever you feed to the common, it will come out of the number 0. So if let's say you're feeding a positive to the common, if you feed a positive to the common, as you can see, let's make it arrow type. Okay. If you feed in a positive to the common, with when it is on, switched on, the positive will come out, and this is what we call as sourcing. So when we say it is a sourcing type, so you, for the common, you need to connect it this way basically. All right. Now this is a AC/DC converter. It's a rectifier, you can say. You can get the power supply from here if you want. All right. And you can use a 24-volt DC output. Now let's study this one. So first of all, NC, you can ignore the first two. Which one? This NC and this NC you can ignore. So when this is NC and this is NC. So I can simply strike it off. I don't need these two for now. This one I don't need. What I need is this first common, which is this one, and the first zero, which is this one. These two I need. So whatever this is my common, as you can see here, this is the common, and this is the output, 0, 0 output. Okay. Once again, this is the common, this is the 0, 0. So let's do the connection. I will connect, since it is a sourcing type, I need to connect the battery source to this common, to this one basically. And then the output side here, the output here coming from here, I will wire it like this. And let me put a load now. Let's put a load here. Let's say the load is a coil. This can be a solenoid coil. The circuit is complete like this. So this is the load here, by the way. This can be a light bulb. This can be a solenoid coil of any valve, a solenoid valve. So you can have a DC solenoid valve, and the moment PLC triggers this 0, 0, then the current will flow in this direction because current flows like this, and it is switched on internally, and the coil is energized. It will open the pipe. This is open the flow here, right? Or this could be a relay coil. That means this is a relay, and then it is energizing these contacts here. Common, normally close, NC, and this is NO. So basis, if it is triggered, then it is triggering the NC and NO. This is, let's say this is NO, this is NC. So it was earlier here, and when it is becoming magnet, it is going to pull this one, and that closes. So then it is what it is doing is, you have to connect some external circuit here. Let's say this is an AC circuit, and let's say this time it is another. Let's say this is a fan. Okay, you're driving a fan using a. So it was driving. The moment PLC triggers, it will stop the fan. Normally close was there, so the current was flowing, and the fan was running. The moment PLC triggers this 0, 0, 1, this energizes, and it is disconnecting this circuit and connecting this circuit. And this circuit could be, let's say, going to another circuit, which is the alarm. So this is an alarm. Let's say I draw the circuit, alarm. So this time circuit is connected from here to here. So the power will flow from here. This time it goes here, and the alarm is triggered. So instead of the fan will trip, fan will stop, and alarm will trigger. So these are the kind of things that can happen when PLC command 0, 0 to be switched. Okay, and this is the sourcing, because it is connected to. The current will come out of this. This is what it means. Current will come out of this, so that it is a sourcing output. I hope we all understood this part. I'll see you in the next video.